Good evening, all of you. Welcome you guys. Good evening to all of you. Welcome you all. So, how you are doing, everybody? कैसे हो सभी लोग? I hope all of you are doing great and all. So, first of all, check this audio video. Am I audible to all of you? Tell me here. Check the audio video clarity. To all of you, tell me, everybody. Yeah. Check this audio video is clarity. Am I audible to all of you? Chalo. I hope we are in live, so am I audible to all of you clearly? So let's start our discussions, all of you. And so before this, we have a great announcement from Unacademy. As you might know, so we will learn everything from the practice as well as the mistakes only. When you can learn anything here, by doing the practice, by doing the mistakes, we'll learn. So whatever the mistakes you have, it is possible you do all your mistakes in the mock test. We need some platform is required for that purpose. We are providing the all India mock test for all the aspirants, that is completely free of cost. Completely free of cost. And so this coming Sunday, that is 18th of this December, also we have a mock test. So all of you do enroll for this all India mock test by using a code of BV Reddy. There you will get a real GATE experience. There you can find the important topics and most expected questions you can get. So don't wait. So all of you do immediately enroll for this all India mock test, and link given in the descriptions. You can enroll for it. And you can plan this Unacademy subscription with a no cost EMI without paying any additional charges. And so plan your Unacademy subscription. If you fellows are interested, use the code of BV Reddy before taking the Unacademy subscriptions. And the complete notes are available. So the two sets of notes are available. It is in the PDF form. You can access in the website as well as a mobile app. And these are the new batches we are starting with the top educators of Unacademy team. Right, so these are new batches we are starting for GATE 2024. You can enroll for these batches by using a code of BV Reddy. And don't just wait, so that start your preparation immediately as soon as possible. And these are the features of Unacademy. So you will get the top educators classes you can access, and then digital notes available, test series, and iconic students will get additional benefits of customized doubt solving feature, and printed notes, hard copies will be sent to your home, one-to-one mentorship, strategy and study program, as well as interactive open house sessions. Fine, all of you? Yeah, first of all, you tell me now here, the last class we have discussed about the electric field and potential for different type of charges. So if we have any doubts in the previous concept, let me know. कोई doubts है क्या, बोलिए आपको? So all these two concepts, and so these notes will be available in the my community in the Unacademy. You can do follow me, so there you can get the complete notes. These hard copies I will share. Okay, so I hope all of you have the clear picture about all the things what we have discussed. If you have any doubts, please let me know. First of all, tell me, कोई doubts हुआ क्या, बोलिए all of you. So any doubts you tell me. We have discussed the point charges and line charges, हमने discuss किया, and we did some problems also finding the electric field calculation due to the line charge. All of you tell me this thing clear, all of you, everybody. Chalo, next one here. Circular ring charge. The next concept, circular ring charge. circular ring charge. Now consider we have one circular ring which is placed in the xy plane. Consider we have one circular ring which is placed in the xy plane. Consider, and this is my x-axis, and this is my y-axis, and this is my z-axis. The circular ring which is placed horizontally, just imagine, and I have placed my circular ring charge such that the center will coincide with the z-axis. Center is coincide with the z-axis. That means I have my circular ring charge which is placed like this. Try to visualize properly. I have placed my circular ring charge horizontally. So I hope all of you can able to visualize. Everybody tell me. Circular ring charge. Fine. So let us, for more clarity, so here assume this is my ring charge. So the charge which I have placed like this, and this is my z-axis. Z-axis is coincide with the center. I place the charge like this. Is it fine, all of you? Due to the charge, yes, it's a ring charge. Ring charge it is. So that means we have charge is there only at these locations. Only at this location we have charged particle. Isn't it? This is a ring charge, like we can say bangle. Like we can say it is a bangle. And let us call this radius of this ring charge, and which we are calling this thing as something capital R. Radius of this ring which is given as what we can say, that is capital R. Now due to this ring charge, I want to find my electric field and potential at a point on z-axis. Yeah, the ring is placed in the xy plane. The ring is placed in the xy plane. Ring is placed in the xy plane. Is it clear to all of you? Tell me. I hope all of you can able to visualize properly. Tell me. XY plane, I have placed my ring. Done. And I want to find the electric field and potential at a point on z-axis. This point we are calling this as 0, 0, h. 0, 0, h. Where this h, which is nothing but that is a distance from the center, that is center of the ring to the point. This is the h. This is the height. So we have a ring charge which is placed in the xy plane. XY plane, this is z-axis. I have taken the point is on z-axis. The distance from the point to the center of the ring is h. Is it fine? Now I want to find the electric field and potential at this point. Let us say this point is something P. So the electric field and potential at the point P, if I call this complete ring having a charge of capital Q, having a charge of capital Q, then I can define the term called rho L. What is this? Rho L is a line charge density. Rho L is what? Line charge density. How this is defined? As a total charge by total length na here. So length of this complete ring, which is nothing but circumference perimeter, that is 2 pi r with the units of coulombs per meters. All of you boliye. Rho L by 2 pi f q by 2 pi r. Now the electric field at the point P due to this ring charge which is given as, and of course we are focusing on the exam point of view, so that's why we are not discussing, we are very nearby the exam. I am not focusing on the derivations. If I start discussing derivation, one derivation will take 1 hour, so here unnecessarily you will waste the time. For the GATE point of view, the derivations are not required. Let us focus on the formulas and then terminologies. Problem solving skills we can focus. So the electric field E, which is given as that is rho L RH by 2 epsilon into r square plus h square, r square plus h square whole power 3 by 2, r square plus h square whole power 3 by 2. Right, and the direction of this electric field, which is along the axis direction, that is along the z direction, which we can say this as az cap. So this is the electric field intensity due to the ring charge, where what is this rho L value, tell me? Rho L is the line charge density, which is given as this thing, which is given as this thing. Can I replace the rho L value here? Can I replace rho L value here? If I replace this rho L, then I can get this thing as this is 1 by 4 pi epsilon. Our basic formula आएगा 1 by 4 pi epsilon into, that is QH by what? R square plus H square, R square plus H square whole power 3 by 2 into AZ cap. Here the axis is along z axis, that's why the direction of the electric field is z directions. Okay, change the axis, then electric field direction also changes. This is the electric field due to the circular ring charge. Now potential V, potential is a scalar quantity. The potential V, which is given as, that is KQ by square root of R square plus H square, KQ by R square plus H square. Potential is a scalar quantity. Done. So this is the electric field and potential. This is the electric field and potential due to what you tell me? Circular ring charge. Circular ring charge. Here you need to understand the terminologies. Each and every terminology we have to remember. So this is nothing but constant 1 by 4 pi epsilon. Q is what now? Total charge of this ring. H. What the H is? The distance from center of the ring to the point. The distance from center of the ring to the point. All of you? Done. Right, next one. Circular arc means if it is a complete circle, we can see. Now it is a arc. So then how the electric field and potential we are going to see now. If it is arc, let us consider this is an arc. This angle which is equal to theta. This is the radius of the arc now. This is the radius of this arc. Now I want the electric field at the center, at the point P. I want at the center, I want the electric field. In that case, the electric field at the center, due to this line charge, having a certain charge we have, that is rho L coulombs per meter. Okay, then the electric field which is given as, what we can write now here, is equal to exactly same relation 1 by 4 pi epsilon into Q by R square, into sine theta by 2 by theta by 2. Okay, so that is 1 by 4 pi epsilon Q by R square into sine theta by 2 into theta by 2. Is it fine, all of you? 1 by 4 pi epsilon sine theta by 2 into theta by 2. Okay. Now the potential. What are the potential V, which is given as potential, so no same, no change at all. 1 by 4 pi epsilon, or we can simply say, call this as a K, we can say. The potential which is given as KQ by R. Potential तो no change, potential is same, and electric field is like this: 1 by 4 pi epsilon Q by R square into sine theta by 2 into theta by 2, where theta is an angle, where theta is an angle. Fine, all of you. Next, yeah, take one problem. A circular ring of radius capital R has a linear charge density. Linear charge density means line charge density, given as Royal coulombs per. Yes, theta obviously radians only hona na. Theta is a radians. Okay, right. Right. So they given which is placed in the xy plane such that it axis coincide with the z axis. Such that it axis coincide with the z axis. The point on z axis where the electric field is maximum. That is exactly this thing only. Now tell me, all of you. ये तो this is exactly same this thing only. Now tell me, all of you. आना बोलिए. Isn't it? What is electric field? You tell me now here. अभी ने हमने देखा the magnitude which is given as what? Yes, exactly. So here this electric field which will be depends upon these parameters, you see carefully, which will depends upon these parameters, right? Right. So what is electric field? Tell me here, all of you, what we can do. One which is given as 1 by 4 pi epsilon into what we can do here. 1 by 4 pi epsilon into what I can say now here, QH by. Tell me now what I can say now. This is R square plus H square power 3 by 2. What I should do, tell me now here. I want to find where the electric field is maximum. To find the maximum value of any function, what I should do here? Differentiate the electric field with respect to H and equate it to 0. Differentiate and equate it to 0. Now tell me now what will get. Now the whole thing is a constant only now. 1 by 4 pi epsilon into Q is also constant. Now here what we can do here? We can apply the U by V rule now. That is given as R square plus H square whole power 3 by 2 into derivative of H, which is 1, minus H into, which will get this as a 3 by 2 into R square plus H square whole power 1 by 2 into the derivative of 2H square is a 2H, and denominator what I will get, to tell me, R square plus H square whole cube. Tell me everybody. Tell me all of you. Now what I can do here, this 2 get cancelled. Now to get the maximum value will equate it to 0 now, tell me. So by equating numerator is 0, that means what I can say here, numerator equated to 0 r square plus h square whole power 3 by 2, which is given as what we can say here 3h, exactly 3h into r square plus h square whole power 1 by 2. Now simplify, get it now. What I will get now here, this is r square plus h square, which is equal to 3h square now. So that means what we will get now, h is equal to, that is plus or minus r by root 2. Tell me everybody, h is equal to plus or minus r by root 2. We have the electric field is maximum. That means the point. What are the coordinates of the point? You tell me. What are the coordinates of the point? I can say now here at a point on z-axis. What are the coordinates? You tell me now. 0 comma 0 comma plus or minus r by root 2. The electric field is maximum. Tell me. At a point 0 comma 0 comma plus or minus r by root 2, electric field is maximum. Done? Chalo. Next one. Let's take the next one. Next problem. Yes, if we put the value of r in the electric field above equation, we can get the maximum value of E max will come. Then E max will come. Next. Take this thing here. A ring of charge is placed in along y square plus z square equal to 4. Can you tell me now what is this thing here? Y square plus z square equal to 4. This is the equation of a circle. What is the radius of the circle? You tell me. 0 comma 0, that is a y value 0, z value 0, and the radius is 4. Yes or no? Center is 0 comma 0. So can you tell me what is a plane this thing? Can you tell me एक कौन सा plane होगा? Tell me. Which is nothing but YZ plane. All of you बोलिए. What I should call this plane is a YZ plane. That means the ring is placed in the YZ plane. Everybody tell me. The circular ring is placed in the YZ plane. And so here, and I need to find the electric field where you tell me a point on x-axis. I need to find the electric field where at a point on x-axis. Ana boliye. Yes, in the ring is placed in the YZ plane. I am taking this is my y-axis, z-axis, and this is my x-axis. Can you take like that? Tell me. And the ring charge which is placed in the YZ plane like this. Now this is the YZ plane and the radius, and radius is given as what we can say here 2, and this radius is given as a 2. I want the electric field at a point on where you tell me 3 comma 0 comma 0. This point is P. Fine, all of you. Now tell me now here. So here the distance from the center of the ring to the point P, this is which we should call it as a H na. So how much is H value? 3. Now what is the electric field formula? Tell me. Which is given as, they given the charge density is given, so we can use a Royal formula. Royal, yes, Royal into what we can say now RH by 2 epsilon into what I can say here r square plus h square power 3 by 2, r square plus h square power 3 by 2. And can you tell me the direction of the electric field? Can you tell me the direction of electric field now? Earlier the ring is placed in the xy plane, axis is along z axis. Now the ring is placed in where you tell me now here? Ring is placed in the YZ plane, axis is along the x direction, so I can say AX cap. Boliye. Now, so just replace now here this all the parameters. E is equal to, we have the royal value, how much now here? 5 into 10 power minus 6. Radius, how much you tell me? 2. And h is equal to 3 by, and 2 into epsilon naught, which is given as 8.854 into 10 power minus 12, right, into what I can say, r square plus h square, means what we can say here, 2 square plus 3 square whole power 3 by 2, and the direction is ex cap. And can do the simplification, get the value now, and do the simplification, get the value. Then बढ़िया. चलो, this line charts, this point clear to everybody. चलो हम आगे बढ़ेगा next one. Yeah, you see this thing here, look at now here. If this question is asked for the center, means what? Center if they are asking, fine. Okay, good question. Look at now here. So what is the electric field E, which we have seen this thing as rho L AH by, tell me now here, 2 epsilon, A is a radius. That is what I can say, A square plus H square power 3 by 2. Right. Now here this A is a radius, and what is the H, you tell me? H is the distance from where to where, you tell me? Distance between center to the point. Center to the point. All of you tell me point where you are finding the field. Now you tell me now here. So if they are asking to find the electric field center of the ring, then the point here will become 0, 0, 0 होगा ना. That means H value 0 होगा. At the center if they are asking, for the center के लिए H will become 0 ना here. If H will become 0, can you tell me what is the electric field, you tell me? Which is equal to 0. The electric field will becomes what now? 0. And what are the potential here? Potential which is given as, that is kq by what we can say, square root of r square plus h square. Now you tell me, if they are asking to find the at the center, means obviously h value 0 na, then whatever the potential at the center of the sphere, which is given as kq by r. You see this thing here, the potential at the center, which is a maximum. The potential at the center, which is a maximum, you see, and the electric field is a 0. Potential at the center of the sphere, which is a maximum, whereas electric field is a minimum. So अगर आपने ध्यान से देखा तो here let us consider I have taken some square, I have taken some regular shape figure. Square I have taken, equal sides are equal. At each corner let us consider, here we have placed a plus q, I have placed here, this is my plus q, here we have the plus q, here also we have plus q. At each location we have placed equal charges, and this is the square, all sides are equal. So this is, let us say this side is A and this side is also A. Now I want to find the electric field at the center of the square. Can you tell me now kya hoga, tell me? What is the electric field at the center of the square? Tell me how much it is. Electric field at the center of the square. Tell me क्या होगा? Yes, what should be? Zero. हाँ ना बोलिए. अगर आपने ध्यान से देखा तो here, so now here because of the charge 1, so this is the field is like this, and this charge diagonally here, this is like this. Because of this charge is like this and this charge is like this, as a result will be all these magnitudes are same, so electric field 0 होगा. Yes, all these values same, so electric field 0 होगा ना. Tell me. हाँ ना बोलिए. The same thing, let us consider equilateral triangle. Let us consider I have taken the equilateral triangle I have taken. This is my equilateral triangle. Yes, now at each corner I have placed equal charge I have placed now here. Here plus Q, here plus Q, here also plus Q. I have placed charges are equal, all positive charges and equal magnitude are located. So tell me the electric field at the center of the equilateral triangle. How much? The electric field at the center of the equilateral triangle. How much? No doubt at all. No doubt at all. The electric field which is equal to 0. No doubt at all. The electric field is center. If the at each corner if we place a equal, all charges are same magnitude, same polarity of charges if I place, and if the sides are equal, then the electric field at the center of the any figure is 0. अगर आपने ध्यान से देखा तो इधर here also let us go the more deep analysis. Look at now here. Here this is my circle. Consider here we have placed one charge. Here we have plus Q. Diametrically oppositely we have placed a plus Q are located. Never say that 0 at origin. It may not be origin, yes, it may be any point. Right. Now, so I need the electric field at the center of the square. Can you tell me what is the electric field center of the square? Now, because of the charge, the electric field is this direction, and because of the charge, electric field is like this. As a result, you see this thing, and this will get cancelled. Ana boliye. This will get cancelled now here. Now you see this thing, how extending this thing, I have placed one more charge here. Here we have placed diametrically, we have located charges. Can you tell me the electric field center because of this? All the four charges. Due to all the four charges, what is the electric field I can say? Due to all the four charges, what is the electric field center? क्या होगा? 0. Hana boliye. Isn't it? Now I am adding the charges, more number of charges I am adding. So this is plus Q here, diametrically opposite location we have placed the charges. Here is a plus Q and here is a plus Q. Diametrically opposite location we have placed the charges. Then see kya hoga. So then like this we have charges. If we place now electric field at the center will become 0. अगर आपने ध्यान से देखा तो if we play the two charges diametrically, electric field is 0. Now 4 charges 0. Now 8 charges 0. 16 charges like this. अगर आपने ध्यान से ऑब्जर्व किया तो if I locate the charges in the form of for the circuit 2 power n, 2 power n, then electric field center will become 0 होगा ना. Tell me. So on 2 power n, the electric field because of the charges it will becomes what? 0 होगा. Isn't it? चलिए. Now here this we have taken the n value we have taken, what you see carefully, n is equal to 1 2 like this we have taken. Yes, regular polygon, exactly. So we have taken n values, we have taken the discrete values. As n value tending to infinity, क्या होगा, tell me? If I take the n value tending to infinity, the discrete values will become continuous होगा ना? The discrete values will become continuous. Then we have charges located at each location. We have charges. So many charge, infinite number of charges are there now. That what we have seen, Avi. That what we have seen at the center. So here ring means continuous charge only. At each location we have charges. So that's why electric field will become 0. Fine, बोलिए. Right. चलो. I told you na, same polarity, whether all are positive, all are negative. If all are positive, all are negative, only it is 0. If all charges are same polarities, all positive, all negative, then only this property. Take the next problem. Two charged rings, each of radius capital R, with charges Q1 and Q2s. With Q1 and Q2s are placed parallel with separation x, are placed parallel with separation x between their centers. Find the electric field and the potential at the center of the rings. Find the electric field and potential at the center of the rings. Now you see this thing, I have two charged rings, each having the radius is capital R, with charges Q1 and Q2s. I have two charged rings. Now are placed parallel to each other, means how the charges has been located, you see. If we consider here, the charges has been located like this. Now if I call this is my x-axis, y-axis, and this is my z-axis. Now consider this is my charge ring 1 and this is the second one. Okay, so each having the radius is capital R. This radius is capital R, this radius is also capital R. Okay, now this will have a charge 1. If I say this is my second charge, if I say this having a charge of Q1, this having a charge of Q2, are placed parallel with separation. The separation, center separation is given as what we can say here, that is x. The distance of separation between the two charges centers, this distance which they call this as x. Find the electric field and the potential at the center of the rings. Means if I call this point, if I say this point is A, so A, and this point is B. Now I need the electric field and potential at the point A and B because of the two charges. Because of the two charges. Is it fine, all of you? Now I want finding the electric field at point A, which is given as what I can say, electric field caused by the charge 1 plus electric field caused by the second charge. Boliye. Now you tell me now what is a E1 is a? E1 is a, I am finding the electric field at point A because of the charge 1. Because of the charge, and for the first charge, where is the point A is A? For the first charge, this is the Q1 charge, where is a point A? Point A is nothing but center of the ring. Now tell me. Point A is at the center of the ring. Yes or no? What is the electric field? Because at the center of at its own center. What is the electric field at its own center? Which is equal to 0. Only A. What is the electric field at the center? H value 0 na. H value 0. So electric field 0 होगा कि नहीं? Plus. Next, what is the E2 means? Electric field because of the second charge at the point A. Electric field because of the second charge at point A I want. Yes, tell me now, what is the electric field? So this point A, which is at a distance of, what you tell me now here, x distance from the center of the second charge. So tell me what I can say, this electric field which is given as, that is 1 by 4 pi epsilon into 1 by 4 pi epsilon into what I can say now here, second charge, which is equal to what you tell me now, q2. Yes, q2, and distance is how much you tell me now, x, by, and here what now here, that so that is given as r square plus x square whole power 3 by 2. बोलिए. 1 by 4 pi epsilon, that is q2x by r square plus x square whole power 3 by 2. Is it fine? Is it fine, all of you tell me? ये आया कि नहीं बोलो. So here how many of you got it now here? सब कमेंट करो. So here कितने लोग को ये बात समझ आया? डन. कमेंट करो कितने लोग को समझ में आया यार. तभी अगर आपको आया तो हियर हम आगे बढ़ेगा ना. सो नहीं तो हियर क्यों जाना. Yes, direction is normal direction. So which is along the, here this upward is positive x and downward is negative x, then which is in the radial direction. Here in this case which is a minus ax direction, you see. Okay, now this is the electric field at point A. Now tell me now, can I find the electric field at point B? Now tell me, can I find the electric field at point B? Electric field at point B, which is given as electric field caused by the two charges E1 and E2 here also. Now you tell me now, electric field because of the charge 1 as well as electric field due to the second charge. Now tell me the E1. So tell me what is a E1 means what? What it is E1 is a? E1 is a electric field where you are finding the electric field now at point B. Electric field at point B, because of what now here? Charge 1. Electric field at point B because of the second charge, isn't it? Now tell me now what we can write. Which is given as, tell me now here, 1 by 4 pi epsilon, 1 by 4 pi epsilon into, we are finding the electric field at point B because of the charge 1 na, q1 charge, q1 and q1x by, what I can write now, tell me, r square plus x square whole power 3 by 2. बोलिए. And the direction is positive x direction. plus, tell me U2 now here. Tell me E2. What is a E2 means? We are finding the electric field at the point B. Point B because of the Q2 charge. The point B is nothing but at the center of the E2 now here, second charge. So this value how much? बोलिए यार, सभी बोलना पड़ेगा. क्या कर रही हो सब लोग बोलो. So which is equal to what we can say? Yes, which is equal to 0. आना बोलिए. That's all. These are the electric field because of the two charges. Is it fine to all of you? Chalo? These are the electric field. Now let us talk about the potential now. We'll find the potentials also. We'll find the potentials also. Tell me the potential if I call VA. VA means the potential at the point A. And that is given as potential due to the charge 1 as well as potential due to the second charge. Potential due to charge 1 as well as potential due to the second charge. Tell me the VA, which is given as what we can say potential at the point A because of the charge 1, which is given as that point is at the potential the center is a maximum na. How much that value? That is K Q1 by R. बोलिए. And what about the V2? Tell me. Potential at A. Potential at A. That potential is due to what you tell me? Second charge. How much distance that charge you tell me? X distance. So what I can write now here? K Q2 by what I can say here? Square root of R square plus X square. बोलिए this thing. Now similarly, can you tell me the potential at point B? Potential at the point B. Potential at the point B, which is given as what I can say. Potential at point B because of the two charges. So which is given as same thing V1 plus V2 होगा. V1 plus V2 होगा. Tell me V1 now here. V1 means what now? Potential at the point B because of the charge 1. This distance is x we have now. So tell me what we can write. K Q1 by what you tell me now? Square root of R square plus X square. And whatever the V2 tell me. V2 is means what now here? Potential at where you tell me? Potential at the point B because of the second charge. So here point B is at the center only na. Point B the center for second charge, right? So tell me how much will the potential tell me? That is KQ2 by what I can say now here? R2. बोलिए this thing. So बोलिए now here. R means R only na. They given R1, R2 given same na, this radiuses are equal radius. बढ़िया. डन. सो ये बात क्लियर हुआ ना कि नहीं, सभी को बोलो, समझ में आए ना. नेक्स्ट वन. Let's talk about next one here, surface charge. Let's talk about next one, that is surface charge. That is a non-conducting surface charge. Non-conducting surface charge. The electric field due to a surface charge which is given as rho s by 2 epsilon. Electric field due to surface charge is given as rho s by 2 epsilon. And the direction of the surface, this electric field, which is given as En cap. En cap. Where rho s is called as the surface charge density. Rho s is called as what? Surface charge density. What are the units of surface charge density? Coulombs per meter square. Coulombs per meter square. How this rho s is defined as a, so the differential charge by differential surface area. Coulombs per meter square, right? And epsilon, we know the permittivity of a medium, and where this En cap is there now, what is this En cap is a, this is a crucial thing here, all of you ध्यान से सुनिए, which is a unit normal vector. It is a unit normal vector. Normal to what? Normal to the given surface. Normal to the given surface charge. And where this En cap is there now, unit normal vector, it may be a positive. It may be positive and it may be negative also. It is positive and it is negative also. And this En which is positive, when it is positive, tell me, if the point lies above the surface charge, lies above the surface charge. Okay, visible now. And En which is negative, when it is negative, if the point lies below the surface charge, if the point lies below the surface charge, okay, where this En cap is a unit normal vector, it may be positive, may be negative. It is positive if the point lies above the surface charge, and it is negative if the point lies below the surface charge. Is it fine, all of you? Now, now take this problem, all of you. Take one problem here. Two infinite sheets. Non-conductor means which is not capable of allowing the flow of charges. Conducting means which is readily available. So if you have taken the material like this, iron, copper, silver, gold, like this, if we apply the certain amount of minimum small amount of energy, it will allow the flow of charges. It will allow the flow of charges. But whereas in case of, let us consider, we have taken wood, plastic, etc. if you have taken, so then what happens now? It does not allows the flow of charges easily, isn't it? For that, to make them as a conductor, we need to apply a very huge amount of charge. We need to apply huge amount of potential. We need to apply 1000 volts, 1000 volts, very high voltage we need to apply. Those are called as a non-conductor. So that's the reason which we used to say, because the nature sigma, based upon the conductivity, we used to define the materials as a conductors and non-conductors. Non-conductors, which we can call them as a dielectric nature. Non-conductors are also called as a dielectrics, and it which is not capable to allow the flow of charges. Take this problem, all of you. Two infinite sheets of charges, they given as a 10 nanocoulombs per meter square minus 10 nanocoulombs per meter square, located at x is equal to 0 and x is equal to 10. Find the electric field, so above the two sheets, below the two sheets, in between the two sheets. Right here, if you see carefully, let us call this is my x-axis and y-axis and z-axis. Here you see this thing here, this is the plane, x is equal to 0 plane. इसका मतलब क्या है? X is equal to 0, इसका मतलब क्या है? So x value must be 0, y and z value can be anything. What's the meaning of x is equal to 0? Tell me. X is equal to 0, only x value must be a 0, and y and z can be anything. Y value can change from minus infinite to plus infinite, and z value can change from minus infinite to plus infinite. This is called as a xy, x is equal to 0 plane, isn't it? So here how we can form a plane such that x value const 0, y and z can be changes. So here if I move parallel to y-axis, so the z-axis, will the any change of x value remains constant now? And if I move parallel to y-axis, there is no change of x value, isn't it? I move parallel to y-axis and parallel to z-axis like this. Now this is the plane we have formed. You can see this is the plane we have formed. You can see now. Have a look at here. This is the plane. Now can you tell me now how this plane here, this plane is parallel to what? You tell me. This is parallel to, this is x, y, z, and can you tell me which is perpendicular to this plane? Can you tell me which is perpendicular to this plane here? X-axis is perpendicular to this plane. Now tell me all of you. So here how this plane now here? The plane is located like this. So here this is like this. X-axis is upward direction now here. So x-axis is normal to this plane, and this plane having a charge. And what type of charge it contains? You tell me now here. Surface charge. How much the lowest value given as a 10 nanocoulombs per meter square is given. And second charge, where it is located now here, x is equal to 10. X is equal to 10 means somewhere here I can say I can move parallel to y-axis and parallel to z-axis. So this is the plane I can say now. We have plane is like this. All of you boliye, we have the two planes placed parallel to each other, one over the other. Now here this x value 0, here x value how much you tell me 10, and this is also having a charge. What type of charge it contains now? Surface charge, minus 10 nanocoulombs per meter square. This will also contain the surface charge. Now due to the two charges, due to the two planes, I need the electric field. Can you tell me where I need the electric field? Above the two. Above the two means what we can say here? Somewhere I can say. Above the two I can say somewhere at the point A. Below the two means somewhere I can say at the point B. And in between the two charges means somewhere I can say C. All of you. I'm calling this, I'm calling as a charge 1, and I'm calling this as second charge. Now let us find the electric field at point A because of the charge 1, second charge, third charge we need to get. Is it fine? यहाँ तक बोलिए सभी को, यहाँ तक. So whatever we have discussed is this point clear to all of you? Now tell me now, let us find the electric field at point A. The electric field at point A, which is given as what I can say here, electric field caused by the charge 1 plus electric field caused by the second charge. Thus vector sum of the two electric fields. What is the E1 is a? E1 is an electric field at the point A because of the two charges, isn't it? So first charge, what is the electric field at point A? Because first charge, and charge 1 is a surface charge now, so which is given as rho s by 2 epsilon, isn't it? Electric field is given as rho s by 2 epsilon. How much we can say here? 10 by 2 epsilon. And En is there now. What is the electric field formula? That is given as rho s by 2 epsilon into En. What is this En cap, you tell me? What is this En cap? Is a unit normal vector. So tell me normal to the given plane na? Here this is the plane. Can you tell me which is normal to this plane? Normal to this charge, x-axis. Now here you see this thing, we need to see whether this is the positive x and negative x, we need to see. Now my charge is at x is equal to 0 and we are finding the electric field at the point A. You tell me the where is the point A now? Above the charge or below the charge? Above the charge or below the charge? It is above now here. So that's why we can say this is plus AX. All of you boliye. Next, electric field second charge, which is given as E2 means second charge. Due to the second charge, I have to find at the point A, I have to find. What is the charge now here? This is minus 10 by 2 epsilon into what we can say En cap. En cap, which is perpendicular to this plane now, tell me, x-axis. Whether this is the positive x and negative x. Here x is equal to 10. I am finding the field at the point A. At the point A. Point A is above my charge or not? So we can say this as a plus AX. All of you boliye. So then what is the total electric field at A? Because the two charges I can say 0. Is it fine, all of you? Now tell me the second bit. The electric field at point B, which is given as electric field caused by the charge 1 plus electric field caused by the second charge. So now you tell me now here electric field caused by the charge 1. Charge 1 at where, you tell me now? At the point B I have to find. At this point I have to find because of two charges, which is given as rho s by 2 epsilon into what I can say, this is En. What is this En, you tell me? I am finding the electric field at the point B because of the charge 1. Where is the point B for the second charge? First charge you tell me. That is above or below? It lies below now, so that's why it is a minus AX. Is this point clear to all of you? Now second one here, that is second charge is minus 10 by 2 epsilon into what I can say here. So because of the second charge, which is at x is equal to 10, we are finding the field at the point B. The point B is below the second charge, so what I can say, this is unit vector is AX negative X. So as a result, what I can say now, electric field at the point B, which is equal to 0 हो गया. Yes. Next, now let us find the at the point C. We'll find now here. So now tell me now, electric field at the point C, which is given as what we can say now here, electric field because of the charge 1, electric field is because of the second charge. अरे यार विकेश थोड़ा, सो हमको भी थोड़ा मौका मौका दो यार. सो हियर आपको पढ़ने के लिए, सो हमको भी थोड़ा मौका दो. सो हियर आप सारा आप किया तो मैं क्या करूं? अरे यार, सो हम जैसा, हम तो गरीब लोग हैं, ये काम करके हमारा घर चलना पड़ेगा ना. ये क्लास क्लास करके ये जॉब हमको केवल ये जॉब आई, हमको कोई दूसरा जॉब तो नहीं ना. हम तो भी कुछ करने दो यार. सो हियर मैं जॉब निकाल दोगी क्या? हाँ यार, अगर हम ये जॉब गए तो हम बेरोजगारी होने वाला. Isn't it? So now tell me the electric field in between the two sheets. Tell me now here. Because of the charge 1, बोलिए now here क्या होगा? And 10 by 2 epsilon into, बोलिए now here. En क्या बोलिए now here. Tell me now here, what is this En cap now? Tell me in this case now. We are finding the electric field at a point C because of the charge 1. This thing we are finding. The here point C is above the charge 1 now. Tell me, so it is plus AX. बोलिए. And minus 10 by 2 epsilon into what we can say. Now at the point, so here where is the point C for the second charge? For the point C for the second charge is above or below? Which lies below now, tell me, so it will becomes minus AX. बोलिए. So the electric field at point C, which is given as what we can say here, 10 by epsilon into AX cap. बोलिए this thing. So this is the electric field at point C. Now you tell me now here, is this point clear now सभी को? Electric field above, below, in between we have calculated, right? अभी आप बोलिए इधर. We have taken now. So what they has mentioned, you tell me now here. They ask you find the above. You take anywhere above. Take anywhere above you can take, and anywhere below you can take. In between anywhere you can take. So this electric field formula is rho s by 2 epsilon. It is not depends upon the distance you see. It is depends upon the charge and the medium only. It does not depends upon the distance. Whether you take here or here, कोई problem नहीं ना. Right, now you tell me now here. Now I have two surface charges. right? So here this having a positive charge, this is assume this is a surface, this is a negative charge. This will having a charge density of rho s, this will have a charge density of minus rho s. Can you tell me the electric field above the two charges? Above the two, can you tell me the electric field above the two? What is electric field here and electric field here and the electric field here? I want. What is the electric field above the two charges? 0, below 0, below 0, then in between, tell me, in between Bolier, what is the electric field now here? Which is nothing but rho s by epsilon. अभी तो हमने देखा ना, बोलिए हाँ, अभी तो हमने देखा, this is the rho s by epsilon. हाँ ना, बोलिए, this is the electric field above the two zero, below the two zero. अगर आपने देखा तो ये क्या है? What is this बोलिए? Now tell me, what is this? ये क्या है? बोलो यहाँ. This is nothing but capacitor. This is nothing but capacitor. हाँ कि नहीं बोलो. So above the two plates of a capacitor, electric field is 0. Below the two plates of a capacitor, electric field is 0. Electric field in between we have a maximum, that is rho s by epsilon. जो बोला अब क्लियर ना आपको चमका कि नहीं? बोलो. rho s by epsilon, this is the electric field in between the two plates of a capacitor. Rho s by epsilon. Done? Fine. Can you tell me the direction of this electric field? Can you tell me the direction of electric field? You tell me. Can you tell me the direction of electric field? The direction of electric field is हमेशा from where to where? Positive to negative. The direction of electric field is हमेशा कौन सा डायरेक्शन होगा? Tell me. हमेशा पॉजिटिव टू नेगेटिव होगा. पॉजिटिव चार्ज टू नेगेटिव चार्ज हमेशा. दिस इज द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. यू टेल मी. ऑलवेज फ्रॉम पॉजिटिव टू नेगेटिव. अगर आपने ध्यान से देखा तो हियर यू सी दिस थिंग हियर. नाउ वी हैव डिस्कस्ड द गॉस लॉ. इफ यू सी केयरफुली, if we have 1 coulomb of charge is there, we have 1 coulomb of charge, how many flux lines can able to produce? If you have 1 coulomb of charge, how many flux lines can able to produce? You tell me. 1 coulomb of flux. According to Gauss law, flux is equal to Q and closure, we used to say na? Right. Let us say 1 coulomb of charge will give 1 flux line. 1 flux line. So from this, I can say this as, for our consideration purpose, easy analysis purpose, assume that 1 coulomb of charge can produce 1 flux line is giving like this. Now अगर आपने मैंने क्या किया इधर, if I place -1 coulomb of charge you have placed here, placed -1 coulomb of charge is placed. Now you tell me this is what's going to happen. Whatever the flux lines which are coming from this 1 coulomb of charge, those will be taken by this -1 coulomb of charge. अरे यार, so होगा ना here. So what are the flux lines coming from यहाँ से? So those lines will terminate and this negative charge. Then क्या होगा? इसके बाद कोई फ्लक्स लाइन नहीं आएगा बाहर. यहाँ कोई फ्लक्स लाइन नहीं ना. So ये तो कहानी देखो इधर. So this positive charges, this and this will have equal charges na. Positive plate and negative plate we have equal charges. So what are the flux line? What are the amount of flux lines are coming from यहाँ से आने वाला? ये negative charge पर terminate होने वाला. Those will terminate on this negative charges. हाँ ना बोलिए. So अगर टर्मिनेट हुआ तो इधर कितना मिला? इधर कितना मिला? कोई भी नहीं ना. अगर इलेक्ट्रिक फील्ड लाइन नहीं तो इलेक्ट्रिक फील्ड इज ऑल्सो जीरो. बोलिए, is it fine? All of you tell me. Clear? चलो, fine. Yes. Fine. Yeah, that's for the today's session, and we'll meet tomorrow. And tomorrow we have the next, we have volume charge is there. We'll complete the volume charge. Thereafter we'll see the some problems. Thereafter we'll do the Poisson's and Laplace equation के बारे में हम discuss करने वाला. Fine. Yeah, that's for the today's class. We'll meet tomorrow. I hope all of you enjoyed the today's class. सभी को मजा आए कि नहीं? सभी को मजा आए ना आज का सेशन में? So we'll meet tomorrow. See you. Bye bye. Good night.